volume on the board. The boiling point of a solution containing 0.20 gram of the substance X. And so this is the solute. The solute is the substance X. And from the parameters we are seeing here, the mass of the solute, what you are seeing here is the mass of the solute, okay? So the mass of the solute is, remember, it is represented as what? Small w. Small w is the mass of the solute. In 20 grams of ether. So this is the mass of the solvent, which we can represent with what? Capital W. Please, this is small w. Small w. This is capital W. Okay? So this is higher, of the ether is 0.17 K, higher than that of the pure ether. So this here is the value for change in T. Is the value for change in T. This is the change in the what? Temperature, or the boiling point. Boiling point. Then, what again? Calculate the molecular mass of X. So this, we are looking for molecular mass of the solute, which is small m, right? Which is small m. So take note. So from the parameters we have here, W is the mass, capital W is the mass of the solvent, small w is the mass of the solute, while small m is the molar mass of the what? Of the solute. So now, quickly, how do we find, okay, the last part, they gave us 216. This value is the Kb, the ebullioscopic, or the elevation of boiling point constant, Kb. So how do we solve this? So let's write the equation to solve this. To solve this, we have that change in T is equal to 1 over W by 1000 multiplied by W over small m. Okay, so this here can also be, everything here, this formula can be reduced to delta T is 1 over W multiplied by W over m times 1000. Okay, the 1000 can come up, right? So that, what are we looking for? Small m, right? So let's make that m solid of formula from here. Let's make this thing solid of formula. If I make it solid of formula from the, where I'm standing here, m will be equal to W times 1000, right? When you cross multiply, so have divided by capital W times change in T. Please, if you don't know how I did this, watch. Cross, multiply, cross and multiply. When you do the cross multiplication here, you will have, when you multiply everything, when you cross and multiply everything by this side, you have change in T times W times n is equal to W times 1000. Okay, so you now make this n sort of formula by dividing both sides by this and this. So that's how we got this. So quickly, that's how we made m sort of what? Formula. So from here now, you can now impute the values. So what is W? W is the mass of the solute, which is 0.20 times, what is the, times 1000. How did 1000 appear here? We are converting this mass of the solvent to kg, okay? So all over W. W is the mass of the solvent. Mass of the solvent, what's the value? 20 grams. So 20 times change in T. Change in T is 0.17. So when you multiply this expression on the board here, so you have the answer to that question. So I believe the answer to that question should be 127. Okay, 127 grams per mole. So this is the molar mass, or the molecular mass of the what? Of the solute. So that is how to get it. Alternatively, if you don't want to solve it this way, there's a rigorous process to this. The process you can use if you don't like this pattern. You can also, instead of using this equation, instead of using this expression to solve this thing, you can just go ahead and use change in T is equal to Kb times molality. Okay, so molality. So what you do is to get the molality first. Get the molality. How do you get molality? Change in T over what? Kb. So molality is simply dividing the change in T, which is 0.17 by 2. The Kb is 2.16. Okay? So molality, if you do this division, you get the molality. So the molality for this guy, the molality will be 0.0787. Okay? That's the molality. So when you now get the molality, you can now go ahead and find the what? The mole. From the mole, you can get the molar mass. So how do you get the molality, the mole? Remember that mole is equal to molality times mass of solvent. Mass of solvent. Okay? So molality is equal to, mole is equal to molality times what? Mass of solvent. So you get the mole. So how do you get the mole? Let's finish it here. Mole will be equal to, our molality is what? 0.0787 times, what's the mass of the solvent? The mass of the solvent must be in kilogram, remember. So the mass of the solvent is 20 grams. So it's going to be 20 divided by what? 1000. So when you do this multiplication and the rest of them, the mole becomes 1.574 times 10 to the power of -3 mole. Okay? So this is just the mole. So from the mole, you can get the what? The molar mass. We are going to get the same thing that we got here. So how do we get the mole now? So mole mass, molar mass or molecular mass is equal to dividing the mass by the mole, and the mass is 0.2. Okay? So the mass is 0.2 divided by 1.574 times 10 to the power -3, so you get 127. So this is how we got this, which is also the same thing as 127 gram per mole. So there are several formats you can use to solve this, but this one is very long. I would advise you can just ignore this one if you don't get it. This one might look somehow difficult, but if you understood it, fine and good. Okay, this part. Okay, but watch this. This is easy. This one is easy. When I did here is simple. So look at this step and understand how we got this. But both of them are the same thing. So these are how to solve calculations involving elevation of boiling point. So the next will be on freezing point of depression.